Hello children, today we are going to discuss the third part of relational function through my fourth video. So here mainly we will be discussing about types of functions. This topic is also familiar to you. Already you have studied in standard 11. Just we will discuss once again the types of functions. In the first one is one-one function. It is also known as injective function. So what is one-one function? So we can define like that a function f is from x to y is said to be one-one function if all the elements of x must have different images in y. In other words, we can say that one element of x is connected with the one element of y. Or if we can say like that, if I take two different elements like x1 not equal to x2, two different elements are taken from x, then their images, that is fx1 is not equal to fx2. Its meaning is if I take two different elements from x, its corresponding images are different. So that is this way we can prove a function is one-one or not. This is one method. Or another way like this also we can prove that if fx1 is equal to fx2, then finally if you simplify, if we can reach x1 is equal to x2, then also we can say the function is one-one. So it can be shown in arrow diagram like this. The function f is from x to y. See x, all the elements of x is connected with other element, and all the elements of x is having only one images. This is a one-one function. So this is the first one-one function. It is also known as injective. Now the second one is many-one function. What is many-one function? Here also a function f is from x to y is said to be many-one if many elements of x is connected with one element of y. Or we can say that if you want, you can say like that. The arrow diagram we can explain it like this. See here, this is many-one function. Many elements of x, see 1 and 2 is having same image, therefore it is a many-one function. So this is the number 2, that is many-one function. So this is 1-1 and this is many-one. Now the next one, onto function. Onto function is also known as surjective. Now what is onto function? Onto function is for all the elements of a function f is from x to y is said to be onto function if all the elements of y should have pre-images in x. All the elements of y should have pre-images in x. See all the elements. See 3 is having pre-image, 4 image, 5 image, pre-image is 3. So this is a onto function. Onto function. That is, here you can see at the same time one element is connected with the one element, so we can say this one-one onto function. Now this one also, if you observe it, here all the elements of y is having pre-images, so this one we can say it as many-one onto function. Many-one onto function. So onto function can be in two forms. It can be one-one onto and it can be many-one onto. And one more thing, if you observe the function defined from x to y, naturally y is known as the codomain. And if you see here the range is also same as codomain. Range is 3, 4, 5, that is the image group. Here also the range is 3, 4, that is the image group, that is same as the codomain. So in onto function we can say that range is equal to codomain. So if you can prove range is equal to codomain, naturally the given function will be a what is called onto function. So this is about onto function. Next we will come to into function. What is into function? Into function, that is a function f is from x to y is said to be into function if there will be at least one element in y should not have pre-image in x. At least one element in y should not have pre-image in x. See here, into function. See, this is the y group, that is the codomain group. In this you can see the element 6 is not having pre-image. So it is 1 function. At the same time you can see there is 1 into function because there is one element is having no pre-image. Here also if you see, I said at least one element. Here you can see two elements are not having pre-images. At the same time many elements are connected to the one. So it is many one into function. So into function also can be in two form. It can be 1 into and many one into. Now one more thing, if you observe it, here the codomain is, in this case codomain is 3, 4, 5, 6, but the range it is only 3, 4, 5. That means we can say that range is a proper subset of codomain. Range is a proper subset of codomain. That is the thing is happening in the case of into function. Here also you can see that range is only 4, 5. It is a proper subset of codomain. Codomain is 4, 5, 6, 7. So this is about into function. This is already you studied all those things in standard 11. Now we are coming to the next one. What is bijective function? What is bijective function? If a function is 1, 1 and onto, if a function is 1, 1 and onto, already you know what is 1, 1 and onto. If a function is 1, 1 and onto, then it is known as bijective function. Okay, so that is bijective. Now we are come to another function. What is identity function? Identity function is denoted by capitalized suffix a. Identity function. Identity function on a it is. So what is identity function? Identity function, you can say like that. A function f is from a to a is said to be identity function if f of x is equal to x for all x belongs to a. F of x is equal to x for all x belongs to a. So this is the definition of identity function. F is from a to a is said to be identity function. Fx is equal to x for all x belongs to a. That is the identity function. Next, after identity function, next is constant function. What is constant function? What is constant function? Because here also we can say like this. A function f is from a to b is said to be constant function if f of a is equal to b for all a belongs to a and b is a constant in b. Small b is a constant in b. So such type of functions we will say constant function. F of a is equal to b. A function f is from a to b is said to be constant function if f of a is equal to b for all a belongs to a. Its corresponding image will be always a constant. So that is known as constant function. So that is constant function. Now the next one is equal function. What is equal function? It is very important. Equal function. What is equal function? Suppose two functions f and g are said to be equal. Two functions f and g are said to be equal. It should satisfy two conditions. First of all, domain of f must be equal to domain of g. Both the functions should have same domain. And number two, Number 2, fx is equal to gx for all x belongs to domain of f and domain of g. If the two conditions are satisfied, then we can say f and g are equal functions. First of all, both the functions should have same domain, and second, fx is equal to gx for all x belongs to domain of f and domain of g. Then we can say that f and g are equal functions. So that is about equal function. Equal function. Next we will come to what is monotonic function. What is monotonic function? In monotonic function you can see this having four subparts. Four subparts: increasing, decreasing, strictly increasing, decreasing and strictly decreasing. So all these things are coming monotone under monotonic function. So first of all I am going to say about what is increasing function. What is increasing function? So increasing function, let x1 is less than x2 from, okay, let it be a function defined from x to y, and x1 comma x2 belongs to x and x1 is less than x2. Then this implies if f of x1 is less than or equal to f of x2, then we can say that the function is an increasing function. Means if x1 is less than x2, then f of x1 is less than or equal to f of x2, then it is known as increasing function. Here x1 and x2 belongs from its domain, and fx1 and fx2 are the corresponding images. So images also should be in ascending order, that is increasing function. So this is about increasing function. Now if it is strictly increasing, we can say like this: if x1 less than x2 implies fx1 is less than fx2, then we can say that it is strictly increasing. If x1 is strictly less than x2, then fx1 also strictly less than fx2. So this is strictly increasing function. Now what is decreasing function? Decreasing function. Decreasing function we can define like this: let x1 is greater than x2, that is in decreasing order. x1 is less than x2 implies fx1 is greater than or equal to fx2. Then we can say that it is fx1 is greater than or equal to fx2. Then we can say that it is a decreasing function. It is a decreasing function. If x1 is in descending order, so naturally this one also should be in descending order. That is a decreasing function. Now if it is strictly decreasing, so again we can say like this: if x1 less than x2 implies fx1 is greater than fx2. If x1 greater than x2, then fx1 is greater than fx2, strictly greater than. So it is known as strictly decreasing function. So monotonic functions are in three forms. First of all, it will be, this is increasing function, this is strictly increasing, and this is decreasing, and this one is strictly decreasing. All these things are comes under monotonic function. Now we will go to the next one. So monotonic function is over. Now we will come to even and odd functions. So what is even and odd function? So what is it? A function f is said to be even function if f of minus x is equal to fx. Then we can say the function is an even function. F of minus x is equal to f of x. Then we can say the function is an even function. This is also you studied in standard 11. So examples, if you want to get the examples like fx is equal to x square, simple example. So f of minus x is also, we can say it is coming to the same thing. So it is x square. See, so it is same as fx. So f of minus x is same as fx, so it is a even function. So this it can be defined as f of minus x is equal to fx, then f is an even function. Now what is odd function? F of minus x is equal to minus f of x. Then we can say that f is an odd function. Here also you can be, you know already the examples. I am taking an example, fx is equal to sin x. Then f of minus x, if you try for f of minus x, it is sine of minus x, that we know is minus sin x. Sine of minus x is minus sin x, so naturally it is minus f of x. Naturally it is minus f of x, so it is an odd function. So f of minus x is equal to minus f of x, then f is an odd function. So this is about even function and odd function. So these are the different types of functions. So you already learned all these things. Most of these functions you learned in standard 11 itself. So once again, one, many one, on to, into, bijective, identity, constant, equal and monotonic function, and even and odd functions. So these are the functions you studied in standard 11. Now we will say about this vertical line test. What is this vertical line test? What is it? Vertical line test is a test we will use to identify the given graph of an equation is a function or not. See, suppose an equation's graph is given. Equation's graph, let it be, this is the graph of an equation y is equal to fx. So what is vertical line test? What you have to do, you have to draw a line which is perpendicular to x-axis anywhere so that it will intersect the graph. Like this vertical line, if you draw it, vertical line. See, many places you can draw a vertical line, and then you see that whether the line is intersecting the graph in one point or more point. If it intersects here, you can see it is intersecting only in one point. Here also it is intersecting only in one point. So wherever if you draw in this case, the vertical line will intersect the graph only in one point. So in that case we can say this graph is represent a function. This graph is represent a function. But if you see another graph, here if I draw a vertical line, see I am drawing a vertical line. This vertical line is intersecting the graph in two places. Vertical line is intersecting the graph in two places. So naturally this graph is not a function. This graph, this equation's graph this is not a function. So this is the way we can check it whether a given graph is a function or not. Just you draw vertical lines, and if it intersects the graph in more than one point, then the graph is not representing a function. So we'll stop it here. In the next class, we'll try to solve few questions based on this.